Okay, good afternoon, Mr. Lee, and to anyone that is watching this. My name is Conan, and this will be my second video evaluation at the date of 27th of September 2021. The total question that I'll be covering here will come from the video evaluation 2 file from Moodle, and it consists of three questions, two for number one and one for number two. I will be using both the handmade graph that is specified to do from the question and also for the graphings, I will also use Desmos. And without further ado, this shall be the start of my second video evaluation. So, the first question, which is 1A, asks us this. Consider the equation as follow, or as you can see on your screen, and without proving so, perform a calculation that suggests whether or not it is a trigonometric identity. Explain the connection between the calculation and the concept of trigonometric identity. So, from that question, we could simply take this equation, the sin square theta minus sin theta plus cos square theta, into minus sin theta plus sin square theta plus cos theta in bracket. And simply put, we can transform said equation into negative sin theta plus 1. Now, the calculation above could also be called as trigonometric identity. The reason for this is because that the understanding of identity is when a given variable will remain true or will always be equal to a certain value. And since the equation above that we just solved, in which we convert sin square theta plus cos square theta into 1, it can also be called as a trigonometric identity, since it uses two different variables to sum up into one certain value, which is 1. Now, moving on to B, it asks us to prove that the equation above, or the problem above that I have given, to be a trigonometric identity. Now, for this question, I will be using the left side and right side method. As you can see, I divide both from the equal spectrum. So the one in fraction shall be the left side, and the one on the right side, or the one with the square thetas, shall be on the right side. Since it's easier, I shall start to do the right side first. 1 second. Now, the right side can simply be boiled down to negative sin theta plus sin square theta plus cos square theta. And we can simply turn that into 1 for sin square theta plus cos square theta. The final answer for the right side of the trigonometric identity is equals to negative sin theta plus 1. Now for the left side, it is cos square theta over 1 plus sin theta. Cos square theta can also be converted is also equals to 1 minus sin square theta. 1 minus sin square theta over 1 plus sin theta can also be translated to 1 minus sin theta. 1 minus sin theta is also equal to the right side, and thus disprove the trigonometric identity for both sides. Now, for number 2, it asks us a few questions. Some of the following is by drawing the graph handmade. It also asks us to identify the amplitude, the equation of the axis, period, so on and so forth. I will explain them throughout the graph, or throughout the question, or the video at least. Now, for number 2, and as you can see on your screen right now, is the handmade graph that I have created on a graphing paper. The points that I have put on the graph will be on 7 for the x value and 52, and the other one is 1938. Now, it asks us to find the amplitude, the equation of the axis, and the period of the graph. Now, for the amplitude itself, it's supposed to mean on how high does the graph goes, like up or down, from the normal or from the midpoint. And to get the midpoint, we can simply take two of the following y-axis, which is 52 and 38, and divide by 2. We should get 45. Now, from 45, we simply just need to know how high or the highest point from that midpoint on basically on how high does the graph go from the midpoint. And to simply put, we can get the amplitude by minusing one of the y-axis or y value with the midpoint, which is 45. So the amplitude will be 7. Now, to find the rest of the question, which is like uh, the period and the equation of the axis, we it'll be too hard for us to determine from handmade graph itself. So I use the help of Desmos once again. Now, as you can see on your screen right now, this represents the function of sin x. And the rest over here, the gx, will be the function for the equation that we are supposed to do now. From what we discussed before, we already know that the midpoint, which is C, is supposed to be 45. Oh, whoops, that's too much. And the A is supposed to be 7. Sorry, that's just too far. There. And from that point, we can also have this. These points represent the 2 points that is, uh, well, the one that touched the graph. And so to do that, we can simply just play around with the horizontal compression or stretch. Now with this, simply put, is not, well, it's not consistent. So the closest thing that we can do is the one that nears to 0, and that is by making it into a decimal. From trial and error, so let's say 1 over 2, near, but it's not it. Over 3, no. 1 over 4, there. By this, we already know that the horizontal compression will be 1 over 4. Or the period, or the horizontal compression will be 4. No, then, uh, so we already got all our elements to create our, well, exponential model. So we can already create it, the equation itself. We already know that a is equal to 7, k is equals to 1 over 4, d is equal to 0, and c is equals to 45. Putting that into the equation, we can simply pull out that the final equation will be 7 sin open bracket 4x plus 45. Now, back to the Desmos again. It also asks us on where or how high the piston will be after 2000 milliseconds. We can simply put all our things again. So simply arrange this. K is divided by 4. There. And these shall be the points. Now we can simply put another point, which is x is equals to 2000. Going all the way past all this. And we should get our result pretty soon. Yeah. So at the point over here, which is at 2000, as you can see, it intertwines with the graph at 41.7. Or you could also say that the height of the graph will be around 42. Okay. So that is it. That was the final question for the video evaluation 2. Thank you for listening, and I am sorry for any mistakes that I have created and or miscalculation that I have made in this video. Thank you and goodbye. Have a nice day.